Alright, so it's just been a minute. Let me get situated. Alright, a couple of things before we get started here. First of all, I am very sorry for the inconsistent airing. Things have happened, things have come up, and I can't guarantee the consistency going forward. I will try to be here every Tuesday and Thursday. The best I can guarantee is up until August 14th. Let me check. So August 14th. I definitely won't have anything aired later that week or the week after. I might come back in September. It's the best I can do. So let's see, what's the next Tuesday, Thursday for that? September. And then Thursday, September 7th, 2023. And then we should be getting on from there. But up until then, it's going to be spotty. I think I may have mentioned before, we're having a baby. And she is 2 weeks from being due. And that has a lot of sway of what we get to do for the next month or so. So bear with us. So yeah, other than that, programming should be as normal. Granted, me and this camera will always go round and round. There she goes. No, like this. This is good. And then I have no lighting. We're good. So yeah, that's where we're at. That's how streaming is going to do. So yeah, that is our broadcasting schedule for now. I will try to be here for the second coming, for this Thursday, the 3rd, and subsequent Tuesday, Thursdays up until August 14th. And then I'll have at least 2 weeks off and see you again in September. So, in essence, we're going to try to wrap up everything we have about fractions before then. And then we'll start on... Sorry, this is the multiplication and division of fractions. We'll start on addition and subtraction of fractions after September 1st. All right. Now, where we had left off, we had just figured out how to multiply fractions, and we did a bunch of rigorous examples of that. But now what happens when you're trying to use it in an application? There are labels, there are words describing your numbers. So we have an example. When you divide two denominant numbers, the units are also divided. This yields a unit in fraction form. So this shows us an example of 250 miles over the course, or divided by 10 gallons. So we can write this as 250 miles, mi being the abbreviation of miles, and 10 gallons, GAL being the abbreviation of gallons. And we can reduce the numbers, but we keep the labels. So 250 divided by 10, they both have a 10 in common. So that is 25 miles per gallon. Because the 25 is now over 1, that's just a whole number, 25 miles per gallon. This is now your unit. This is a new name, miles per gallon. And this has probably sounded familiar. So you're trying to figure... Oh, wrong one. Sorry. You've probably tried to find out like what's the best gas mileage? Well, if you can go 25 miles per gallon, that's not very high compared to other vehicles. But you can compare miles per gallon of this vehicle and that vehicle to determine the best gas mileage. So when we have one divided by another, we can rewrite this as miles per gallon. And because miles is divided by gallon, the division mark is pronounced per gallon. So another example. I'm trying to get it to where you can see it. I'm sorry. Right there. Have to label out my desktop to remember where everything is at. It's a good idea going forward. So if we're given the example 360 feet divided by 30 seconds, abbreviation is FT and S, so we get 360 feet per 30 seconds. They both have a 30 in common, so that'll reduce to 1. 30 can fit into here 12 times, so that is 12 feet per second. So that is just telling us how to divide and how to set up our fraction. So if we are given something, such as 25 miles per gallon times 12 gallons. So if you have 12 gallons in your tank and your vehicle gets 25 miles per gallon, how far can you go? Kind of question. So this is 25 miles over gallon. And there's a 1 under here because this is a whole number, so we can simply put it such as like 1 gallon on the bottom. This is multiplied by 12 gallon. And there's nothing under here, so there's just an understood 1. Because this is a whole number, and a whole number divided by 1 is itself, therefore we can have an understood 1. And nothing reduces, so 12 and 25, that is 250 plus 50 is 300. But in this case, we have labels, and we have a gallon here and here on the denominator and the numerator. And just like finding common factors, if you have a label on the denominator and the numerator, these can cancel out. It's a nice, simple thing. So all that's left is miles. So that is how you would label your answer, 300 miles. So the question, your car gets 25 miles per gallon, and it has 12 gallons in the tank. How many miles can you go on how much gas you have? You can go 300 miles. So it's that kind of question answer to your question. Okay. We also have an example of 12 feet per second for 1 minute. Well, 1 minute equals 60 seconds. So what this means for us, because we know this, 12 feet per second times 1 minute, which is 60 seconds. So that is 60 seconds. And we can just label this as 1 minute because 60 seconds can fit into 1 minute. We were asked about the minutes. So because we know 1 minute is 60 seconds, this is the same as 60 seconds per minute. And that is very important for how we write it here. So we have seconds in both the top and the bottom. So those cancel out. So then we get 12 times 60, which is 720 feet per minute, or 720 feet per minute. Yeah. The best thing to advise on these kind of questions is to read the problem as carefully as you can to determine the given information and what you are asked to find. So, if we can get another example going forward. We have So this question asks, Lisa worked 10 1/4 hours per day for 5 days. How many hours did she work? So we have hours per day. So we have 10 1/4 hours per day for 5 days. So 5 days. And how many hours did she work? Well, if we worked 10 1/4 hours per day for 5 days, that is 10 1/4 times 5. But first, let us get a mixed or a improper fraction so we can multiply better. So 10 times 4 is 40, plus 1 is 41 over 4 hours per day. And in this case, it does not really matter if this number is in the numerator by itself. Because what I had a moment, 41 over 4 is the hours per day. So I was having this imagined 41 over 4 divided by 1 day. I was like, well, not necessarily. You have a fraction. You just need the hour and the day to be in the numerator and the denominator, respectively. Times 5 days. And just because it's a plural, it doesn't matter. It is the same descriptor. Just because it's spelled differently, day and days, it is still the same unit. And this is the understood one. So we have 5 times 41 is 205 divided by 4. And these days will cancel out. We have 205 hours. And 4 can fit into 205. 51 1/4 hours. Yep. Now, something that you may see, you can, because you have 10 hours per day plus 1/4 hours per day times 5 days. If you want to multiply this one first, that one's pretty simple because, again, this is distribution. So 5 times 10 is 50. And cancel the days. But because, yeah. So you've canceled the days with this one. And you can also cancel the days with this one. So 5 times 1 over 4 is 5 over 4. 5 over 4 can be rewritten as 1 and 1/4 plus 50 is 51 and 1/4 days. So multiply the pieces if that's easier for you. Rewrite it as an improper fraction if that's easier for you. But always make sure if you're going to multiply the pieces that it is a distributing factor, not multiplying both incorrectly. All right. So we have, use a new side of the paper. Oh. So we have okay. So this says a sheet of notebook paper measures 6 3/4 inches wide and 8 2/3 inches long. Find the area of the paper. Just as we did previously, we are given the finding of area. We multiply the width times the length. And if we multiply the units, it becomes those units squared. And why is this so bright? So we have 8 2/3 times 6 3/4. And inches times inches will be inches squared. And go ahead and square our units because that's all we need to do with those. And so you can either have 8 plus 2/3 times 6 plus 3/4, or you can change these to improper fractions. So 8 and 3 is 24. 26 thirds times 6 and 4 is 24. 27 fourths. Working with improper fractions is a little easier. The 3 and 27 cancel out. A 3 can fit in 27 9 times. 3 into 3 once. You can reduce no more. So 9 times 26 is 180 and 54. So that is 234 divided by 4. 4 can fit into 234. 58. And remainder of 2, which 2 over 4 can reduce. So 58 and 1/2 inches squared. Now we're going to check our answer with this distributive method or the FOIL method. So we multiply the first, outer, inner, and last. 8 times 6 is 48 plus outer. We have 8 times 3/4 8 and 4 can reduce. 1 and 2. 2 times 3 is 6. And inner, we have 2/3 times 6. The 3 and 6 reduce. 2 times 2 is 4. Plus 2/3 times 3/4. The 3 and 3 can reduce, so that is 2/4, which, this can reduce. 1 and 2, which I'm seeing that the 26 and 4 could previously reduced. I just didn't see it. And so it ended up being reduced later. It will reduce when you can see it. So then 2/4 is actually 1/2. So 48 plus 6, that is 54. 54 plus 4 is 58. 1/2 inches squared. So yep, either way you go about it, that's how you find the area. That's a peculiarly complicated. Let us do something very similar. So a window is 4 1/2 feet high by 2 1/2 feet wide. What is the area? So that is the 4 1/2 by 2 1/2. So you can either do 4 plus 1/2 times 2 plus 1/2, or 4 times 2 is 8 9/2 times 5/2. So first, 4 times 2 is 8. Outer, 4 times 1/2 is 2. Inner, 1/2 times 2 is 1. And last, 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. So 8 plus 2 is 10. This one is 11. So 11 1/4 feet squared. And here, nothing can reduce. So we have 9 times 5, which is 485, divided by 2 times 2 is 4. 4 can fit into here 11 times, with remainder of 1, divided by 4, so 11 1/4 feet squared. Yep. So going forward, it is pretty much the same thing. Otherwise, it is just how it's worded. So we are going to go ahead and jump into the examples here. Oh, there seems to be a lot of them. Let's see. Oh, there are only 30 examples, but they're all word problems, so it may take a moment. Well, we will try our best to do all of them. So, if you have any questions, comments, concerns, please reply or leave a comment below, subscribe, get back to me. So number 1, evaluate the following. Be sure to use proper units. So number 1 has 36 miles per hour times 4 hours. So 36 miles per hour times 4 hours. We have these understood ones, and 36 times 4 is 120 plus 24, so 144. The hours cancel out, so it's just miles. We're asked 80 calories per gram times 5 grams. So that is 80 calories per gram times 5 grams. 80 times 5 is 400 calories, and the grams cancel out, so that's just 400 calories. Three, we have 55 joules per second times 11 seconds. So 55 joules times seconds, times 11 seconds. So seconds cancel out. So 55 times 11 is 5 times 121, if you want to rearrange it. So we have 5. I believe we have 605 times 11. Yep. This 5, carry the 1, 605. So 605 joules. Always remember to label your numbers, because numbers are adjectives and they are describing what. So knowing what it's describing is very, very important, especially if you're talking between joules and calories. It's kind of important to know what you're describing. Okay, number 4. Okay. We have 5 pounds per foot times 3 feet. So that is 5 pounds per foot times 3 feet. 5 times 3 is 15. Feet cancel out, so that's just 5 pounds. We are provided with 88 feet per second times 1 minute. It's gotten long complicated, but no worries. 1 minute over 5,280 feet times 360, seconds per hour. The significance of these two numbers, if you care to know, there are 5,280 feet per 1 mile. And this is just fun to know. You don't have to know. And then 3,600, there are 3,600 seconds in 1 hour. So we have this 88 feet per second. And you can write your S's however you like. I just prefer it the one way. Sometimes I forget, and I use the other way. The printed as opposed to cursive. Times 1 minute per 5,280 feet times 3,600 seconds divided by 1 hour. So we divide what we can. So we have the feet and the seconds. And then we are left with the minutes per hour as our descriptors. And then we have 88. 88 in the numerator, 3,600 in the numerator, 5,280 in the denominator. Now, we can reduce. Reduce is very important. And since they are multiplying, you can reduce from wherever you can inherently see. So there's a 0 and a 0. These are both divisible by 10. So 528, 3,600, still divided by 2, or they're divided by 3. If they're divisible by 2 and 3, they are divisible by 6. So 6 can fit into 52, 80, 8 times. And then 6 can fit into 36, or 360. 6d times. Now that's super nice that we have 88 and 88. So that comes out to be a nice even 1 for the both of them. So we're left with 360. Now we're left with 60. 60 minutes per hour, which is correct. It takes 60 minutes to circumnavigate an hour on the clock. So that is correct. It's a very convoluted way to get there, but it is correct. Six. We have 24 hours per day, which is true, times 3,600 seconds per hour, which is also true, times 365 days per year, which is technically true. The reason why we have leap years is there's technically 365 and a quarter days. So once we have 4 years in a row, we have an extra day. So then we have 24 hours per day times 3,600 seconds per hour times 365 days per year. So we are getting rid of these days and hours, and we are finding out seconds per year. There's going to be a lot of them. So bear with me. Alrighty. So we will start with 600 times 24. So that's 7 times 4. Yes. Okay. So what I did here, I was 2 times 36 is 72. 1, 2, 3 zeros. And 4 times 36 is 2 times 72, which is 148, with 1 and 2 zeros. So then we have 800 times 365. So by the 5, we have 0, 0, 40. Sorry, 4, 0, 4D. So 5 times 6 is 30. Drop the 4. 5 times 8 is 40. Drop the 43. Start over. 6, 0, 0. That's 48. 48. 36 plus 4 is 4D. Golly, 6 times 8 is another 48. So 50. 52. So 3, 0, 0, 24, 18, 20, 26. That's a lot of zeros. 4 plus 8. 4 plus 8 is 12. 1 plus 3 is 4. 4 and 4 is 8. 4 and 2 is 6. 5 and 6 is 11. Carry the 1. 1 and 2 is 3. So we should have somewhere in the ballpark of 31,682,000 seconds per year. Now, because I am confident, but I'd want to check my work, I need a calculator, and that's a lovely item. So 24 hours in a day times 360 seconds per hour times, oh, see right there, that 86.4, I did something wrong there. So this is wrong. So that probably means our whole answer is wrong. Times 365. So we should have gotten something like 31536,000. You know what this means? We get to go back and figure it out again. Because figuring out how to do something is more important than what we have done. So 360 times 24. So 24, 0, so 0. 2 times 6 is 12. 2 times 3 is 6, plus 1. So that was fine. But we have these two zeros. 4 times 6 is 24. 4 times 3 is 12. 13, 14. 144. 0, 0, 4. 2 and 4 is 6. 7, 8. So then we have 86,400 times 365. So 0, 0. 5 and 4 is 20. Carry the 2. 5 and 6 is 32. Carry the 3. 5 and 8 is 43. Carry the 4. Nowhere to carry it. 6, 0, 0. 6 and 4, 24. Carry the 2. So 6 and 6 is 36. 37, 38. Carry the 3. 6 times 8 is 48. 49, 51. 3, 0, 0. So 3 times 4 is 12. Carry the 1. 3 times 16 is 18. 19. Carry the 1. 3 times 8 is 24. 1 is 25. So now we have zeros, zeros, zeros. 2 and 4 is 6. 3, 8, and 2 is 13. Carry the 1. 1 and 9, or 1 and 9 is 10. 11 plus 4 is 15. 1 plus 5 is 6. Plus 5 is 11. So 3, 1, 5, 3, 600. So we eventually got there. Thank you for hanging with me. Okay, so that was number 6. Number 7. Maria earns $11 per hour. Last week, she worked 9 hours per day for 6 days. What was her gross pay? Now, something I've always had an issue with, but I figured it out. Gross pay is what you get before taxes and insurance and retirement. And then after taxes, insurance, and retirement, it's net pay. Because It's what went through the net of taxes, insurance, and retirement. Fun to know. So gross pay is before taxes. Net pay is what's gotten through the net of everything else. So we were given $11 an hour, 9 hours a day for 6 days. So that's $11 per hour. Now I put the dollar sign on this side because all of our descriptors on this side, I don't know why we don't. I mean, we say $11. We say $11, and dollars is always on the right. Personal discrepancy. This is fine. 9 hours per day times 6 days. Big on. Oof. So, the hours cancel out, the days cancel out. The only thing we have left is the money. It's kind of nice. So 11 times 9 times 6. So 11 times 9 is 99. 99 times 6 is 54. Excuse me. 54 again. So $594. So, number 8. The gas tank in Luigi's Toyota Camry holds 17 gallons when full. So we just have 17 gallons per one Toyota Camry. The car gets 21 miles per gallon. How far can he travel on 3 full gas tanks? So this is 1 multiplied by 3, and it doesn't matter if you multiply it by 3 over here or there, because that is the rule in multiplication. That order does not necessarily matter. So then we have 17 gallons times 21 miles per gallon times 3, because we have 3 tanks. Well, technically we can label this as 1 tank, and then we have 3 tanks. So the gallons will cancel, the tanks will cancel. The only thing left is 17 times 21 times 3. So let's see. Let us multiply 17 by 21 first. So that is 340 plus 17, 357 times 3. And then 7 and 3 is 21. 3 and 5 is 15, 16, 17. 3 times 3 is 9. Carry the 1, so you should have 1,071 miles. Nine. Yep, 9. So a recipe calls for 2/3 cup of sugar for each serving. How much sugar is needed for 6 servings per serving? So let me get my hand out of my way. So 2/3 cups per serving times 6 servings. So that is 2/3 cup per serving times 6 servings. The servings can cancel out, so you're left with 2 times 6 is 12 divided by 3. 12 divided by 3 is 4 cups of sugar. And that's pretty nice to know, especially when you are working with recipes. Fractions are insane, so you will need to know a lot about them with recipes. The next one, Mom's French toast requires 3/4 cup of batter per serving. Per serving. If 5 people are expected for breakfast, how much batter is needed? Well, let's say each person only has 1 serving, because this is an ideal world and we eat only 1 serving. It's kind of funny, but definitely not true. So 3/4 times, 3/4 cups per serving times 5 servings. Servings cancel. 3 times 5 is 15. 4. And that can be rewritten as 3 3/4 cups. Eleven. A patch of dirt needs 3 5/6 square feet. So square feet can also be written as feet squared of sod to cover it. If Nick decides to cover only 3/4 of the patch of dirt, how much sod does he need? So let me get this straight. We have this patch of dirt, and to cover all of it, we need 3 5/6 feet squared. But we're only covering 3/4 of it. Oh, well, I see. So then, it's still multiplication. I was skeptical. I just wanted to check. 3/4. Dirt. So this doesn't actually change any of the descriptors. We're just getting 3/4 of the sod. So we can do this. We're going to use improper fractions for ease. 3 and 6 is 18, plus 5 is 23, times 3/4. The 6 and 3 can reduce by 1 and 2, or by 3, leaving 1 and a 2. So that's 23 over 8. Can be rewritten as 2 7/8 feet squared of sod, because we're describing square feet of sod. 12. Well, I guess we will not get all of these problems today, but I hope you've gotten the gist about how labels work with fractions. That is pretty much what we're going over today. And before I do this next problem, give you a heads up of what is coming up. Then the next, we're going to start division of fractions next time. Hopefully that is this Thursday. If by anything, it'll be next Tuesday. So the next section is dividing by fractions. So 12 says a driveway requires 4 5/6 cubic yards, or yards third, of concrete to cover it. If Sheila wants to enlarge her driveway to 2.5 times its current size, so instead of this size, it's going to be 2.5 times the current size, how much concrete will she need? So here we have 4 5/6 times 2.5. So 4 times 2 is 8. Squish this over here. Sorry. 4 times 2 is 8. 4 times 1/2 is 2. 5/6 times 2 is 10/6, which, because 5 times 2 is 10 over 6, that reduces to 5/3. And then 5/6. Oh, let's just keep that with 10/6. I'm sorry. Yep. And so then we get 5 times 1 over 6 times 2, which is 12, which they don't have the same denominator. We'll go back over later how to add, but you need the same denominator in order to add. So to make 6 and 12, you multiply it by 2, and so what you do to the bottom, you do to the top. So you'll have 20 twelfths plus 5 twelfths. So 8 plus 2 is 10, plus 25 twelfths. 12 can fit into 25 2 times, leaving 1. So that should leave you with 12 and 1/12 cubic yards of concrete. And I'm going to check my answer here, and I think we'll go ahead and wrap up for today. So then we have 4 and 5/6, which can be rewritten as, say, 24 29/6 times 2.5, which is 5/2. Neither can reduce, so 6 times 2 is 12. 29 times 5 is 145. And 12 can fit into 145 12 times, with the remainder of 1 yard cubed, or cubed yards. Yeah. I believe that should do it for today. Please let me know in the comments. I try to go back and check those to make sure. If anyone had any questions, I'll address them in the next video. If not, I will reply to the comment when and where I will try to reply that to. So we might indeed have some YouTube shorts of trying to answer questions. That'd be great. Please let me know what else you may need help with other than just fractions right now. I will be going linearly through a textbook on these topics. Once I get done with this textbook, we're going to the next level up. So from here, from basic math skills with geometry, we're going to go into algebra. But we probably won't get there until the next year, so 2024 sometime. I'd imagine people have a lot more other questions and other topics of math other than general math skills before then. So please let me know. I'll be welcome to stop and address that. So yeah, that is the hope, to be here and be a math lab for people with questions. I know if that starts to pick up, we may never finish this textbook. That would be kind of fun. I wouldn't mind. But in any case, without that being a thing, we're going to go ahead and work with division of fractions next time, hopefully this Thursday, August 3rd, or next Tuesday, which would be August 8th. With that being said, I will see y'all the next time. Thank you.